Thank you very much for this invitation. I feel very honored to be here in Beijing and to provide a lecture that is also where people can also listen from other parts of the world. And today I want to look into, well, three different aspects of environmental compliance monitoring. I will briefly say what it is, particularly looking into the role of the geospatial, GIS, geoinformatics, geospatial data in that field. And then lastly, a little bit giving an outlook or looking at very recent developments of AI and how that influences our field. So when under this umbrella term, environmental compliance monitoring, I understand compliance with environmental laws, regulations, standards, also requirements for companies to produce something on a site and to report about environmental conditions, managing monitoring programs or schedules. But it's also about pre-processing, performing calculations and validations of data for the reporting and routinely producing compliance reports. Examples include, sorry that I don't include here China. I searched the internet, but I didn't want to talk about things where I don't understand much. So I mainly concentrate on Europe. I bring a couple of examples from the European Union, but I also refer to the United States, where they have clear environmental acts like the Clean Air Act, the Clean Water Act, etc. In Europe, and I have an extra slide on that later, we have a lot of these abbreviations on various directives that need to be translated into national laws. And I will come back to two of them, the Corporate Sustainability Reporting Directive, particularly forcing companies to report on how they are doing, not only with the environment, but also with their employees and their general sustainability. And I will also particularly look very briefly into the European deforestation regulation. We believe what we see is now that we are able, this is kind of a hypothesis, but I also refer to a recent paper by Rossi et al. That this group of authors show that we can establish almost automated workflows for reporting to many of those environmental compliance regulations with existing data sets, with open data sets, and with standardized workflows, hopefully also being open. But that brings me now to the basic concepts of GIS going back. I have been teaching that for many years. And I typically start with this phrase from the first GIS textbook from Peterborough. And please don't take me wrong, it was a fantastic textbook at that time. But it basically says that every geographical phenomenon can in principle be represented by a line, point, a polygon, or by a raster. And that was the situation probably described in the 1980s, and I will now go a little bit into some examples where this actually reaches some limits or limitations. For instance, if we deal with a complex environments that many of us would intuitively call nice or would feel home or feel comfortable, this is, by the way, is a Water Street, a little Water Street, a Gracht in Amsterdam, and there's a quite high lively livability factor, and this shall make us think how we can represent that in a GIS or through Earth observation data. So I claim that GIS as a method and a tool and a service and a system is widely established. Algorithmic problems are widely solved. We have the computer power nowadays. We have huge data sets, it's usually not so likely a scarcity of data that limits us. But we may now need to go beyond pixels and beyond vectors, addressing the human dimension. And I will give a few examples, or look a little bit into how this looks in, or what this has to do with environmental monitoring and reporting. So I'm often starting with examples like those here, having a little bit of a background in landscape ecology. And when working with different types of landscapes, we love to give names to those landscapes. We call particle elements an orchard. We call this nice landscape in the middle a pond landscape, or we talk about suburbia. All things that are not so easily being operationable, measurable in a computer system, if we stick to this very classic, and there is nothing wrong about it, raster-based system, or on the right-hand side, a vector-based system, in principle, having vertices, lines, and polygons, and then attributes attached to that. So that was the classic world in GIS. Again, it's a little bit exaggerated. This is 1980s style, 90s style maybe. And I've worked for a couple of years on concepts of place-based GIS, and generally trying to bring in also some social aspects, behavior, and cognition into those data sets. This is from a publication where 6 authors looked into 6 different languages, how place and space, including Chinese, including English, including German, Spanish, how place and space is considered in these languages, and what particular problems arise. So I can only briefly go into that. So it's in English language, we clearly distinguish between place and space, and I would like to, in many instances, I would like to incorporate or go beyond a pure geometric consideration, particularly when it's about sustainability reporting. Of course, it was then exactly, and I have a practical example on that, difficult to operationalize then the measures that we need to say, yes, something is fulfilled or something is not fulfilled. We very often need to discretize in a way to say, yes, something is fulfilled, a law is obeyed or not. So we are very often forced for this type of 0 and 1 discretization. So my good child has often nicely distinguished here in one of his papers between space and place, and he also said in one place that in one of his papers that his space is is almost boring, or it's the most problems are solved, whereas place, the contextuality, the vagueness is, and the ambiguity of concepts, that's the challenges that we typically have in geoinformatics and GI science and geospatial research. So a while ago we looked into place-based GIS, and here we distinguish, but I just touch upon that, there are various ways to approach it, coming from ontologist semantics corner, coming more from a place names, place modeling direction. Critical GIS played a little bit of a role particularly in the 1990s, and people dealing with, so researchers dealing with qualitative aspects, but this is still a minority. All what we see here, we're talking about a couple of 100 papers, whereas geospatial is in literally several 10,000 of papers per year. But I claim that place and space are somehow related, and this is a picture that a PhD student of mine drew a few years ago before AI, So I'm a little bit proud of that, and I will now try to translate that into environmental monitoring regulations and requirements. So I will go into two directions: deforestation as one example, and SDGs. But today only very shortly. I have another presentation this week on SDGs. So corporate social responsibility and also deforestation so far were very rarely legally binding. We were missing very concrete measures. But this has changed now, and I will show this example of the European side. There are also very strict deforestation laws in China, actually for longer, and also the US and the UK has deforestation laws. They would, in the UK and in the US, they particularly look at the point if timber is legal or is illegal. If it's imported particularly. Whereas the European Union's definition or the target this goes much beyond that. The reason behind is that there was a study that in Africa 85% of the deforestation of the last 20 years can be attributed to 7 commodities that are listed down here. Coffee, palm oil, cacao, soya, rubber, and timber. And the European Union says we don't want to be guilty anymore for this deforestation, particularly in Africa and in some parts of Southeast Asia and South America. And so they're coming up with this very strict regulation, and that regulation we will see in a minute. In the law, it talks about satellite imagery. It talks about GeoJSON that you need for the geolocation of fields where your coffee was grown, where the beans were grown, where the cacao comes from. But it also says that the land has to be legal. So it's not okay if somebody. If it's not deforested, but it has been taken away from smallholder farmers some years ago illegally. So there is now here on this slide, there is a couple of, and I will just really very quickly go over. I should just show you that this is a very comprehensive regulation, and this is for us for building geospatial workflows. It's a huge effort to automate these processes. It has been delayed by 1 year, but it seems to be fixed that this is not true what we see here. It has been delayed by one year. Sorry, I have the old slide. It's now enter into force end of December this year, and it will affect 10,000s of companies, and they need to, for every container of cacao, coffee beans to be shipped, they need certificates where it comes from. It needs to be polygon data, GeoJSON, and it needs satellite imagery that compare the situation of 2020 and now. And this, at first glance, seems to be a straightforward field for remote sensing people. Great. We use data from the archive for 2020, and we use recent data, and then we can compare. Is there any deforestation? But we went into that with greater detail, and we find that there is some great methodological problems. Most remote sensing scientists, for many years, they think in pixels, and basically what you typically calculate is biomass per pixel. And then we say, okay, there's a lot of biomass and there's little biomass. And then we kind of estimate the forest out of that. And we do that for 30-meter Landsat, for 10-meter Sentinel, or for very high resolution data down to less than a meter resolution. But this European deforestation regulation has a definition that says that forest is something where trees are higher than 5 meters and have a certain coverage. They cover more than 10% of the ground, etc. And it's a certain minimal mapping unit size that you can call something a forest. And that gives us quite a headache for many of these automated workflows where there are big companies. I shouldn't name them now here, but there are big companies who say we have that enforced. Just give us your data, and we tell you if you're violating deforestation regulation. But it's not so easy. That was the one example, and the second one. Sorry to be brief here again on SDGs. I can't touch all of SDGs, and I assume that the audience here at least knows about the 17 SDGs. And this is a great thing that we really made after the Millennium Goals that were not so concrete and tangible. We really came up, the UN in 2015 came up with measurable, with goals, with targets, with sub-targets, and with indicators. And there are 232 indicators, and there are lists by some UN organizations how many of those indicators can be fed by remote sensing data, how many of them are related to GIS. But I want to bring you one little example for one of these 232 indicators where we worked on. That's called, the indicator is called 11.7.1, and its full name in the Sustainable Development Goals is called Average Share of the Built-Up Area of Cities that is open space for public use for all by sex, age, and persons with disabilities. And like with all of these indicators, every country who has in the world, basically for being member of the UN, shall every 2 years report on the amount of that space. And that seems so straightforward that you use your remote sensing data and then you say, okay, in Beijing, we have we have this and this share of built-up area that is open space for public, etc. And in Paris, we have so and so many. And in Buenos Aires, we have so and so many space. But when you go into detail, it's not easy because it says open space and it can be used, and it can be used by different groups. And you are not necessarily sure if a park might be fenced and it's not accessible for everybody. So remote sensing alone is difficult, and it should also be easily accessible. And there are some attempts. And in this little paper, we looked into an operationalization that is kind of an Austrian way of reporting, and unfortunately there are some small differences in the reporting. Nevertheless, of course, the overall aim to get an idea about the whole world of each of the targets and each of the indicators is still valid. But again, I just want to show you that here, even so, it sounds very straightforward, very tangible, very clear. The implementation is still problematic. What may help us are generic classification schemes that classify urban form in a very structural, in a very generic way, so that you can, let's stay with my ad hoc examples of Buenos Aires or Beijing or Paris, that hopefully urban fabric, mixed land use, or storefront types are comparable. And there are some attempts worldwide of such such generic structure of built-up, non-built-up bare soil, vegetation, water, and then going down in a hierarchical system. And a former PhD student of mine, we published a paper in 2019 where we suggested how to break it down in a way that that remote sensing data can accommodate that model, and we can translate it to actionable results, hopefully. But That shows us that, yes, we do need these generic type of models, and we need classification systems that account for the humans living there. And this is now really the duality, or the dualism, or between being tangible, coming up with measurable results, coming up with results that you can count, 8.4 hectare per person, whatever, and at the same time also somehow reflecting the vagueness of place, how people feel, how people, what's about the livelihood of people. And there are many attempts, like here, a paper that we wrote a few years ago. And so we looked into place, space, feelings. We looked into quality of life and livability. Is this the same? Is this the same concept? And how can we draw from the different worlds, from sociology, from social geography, and from more technical fields in geoinformatics, geoscience, and geospatial data processing? Because I like this picture here that a colleague of mine and psychologist took many years ago on this park bank in Spring. I hope that he got the permission to publish this, but I'm using this for 15 years probably. That shows that the measured temperature here in a Sunday in spring in Europe, like 15 or 20 degrees, is maybe very different for these two persons sitting here on this bank. Okay, and I think that shows a little bit. I hope it expresses what I mean with this livability, and that this is the challenge to bring it in. Of course, we don't have to in many places, but for some things we should. And there are attempts, particularly in our institute at ZKIS at the University of Salzburg. We have a tradition for quite a while, where we're using regionalization concepts and coming up with homogeneous areas that go beyond administrative boundaries, that are flexible, they're building on object-based image analysis, that I've on one of the next slides, but going beyond the image dimension, all by integrating information, relatively homogeneous information into. There's also called the geon concept, from a Greek word geon, developed by Stefan Lang and colleagues, and now we see when AI comes in, and this is the last part then of my talk, when now AI is doing that all for us. And we will challenge, or we will ask ourselves, can AI also account for all these livability? I claim, or I say, that at least where we started is old concepts of scale and hierarchy in ecology that we translated some years ago into something that we called object-based image analysis, and we modeled classes semantically. We can build upon. We can say, okay, the class inherits some characteristics from another class, and though we can come up with something that is beyond land cover, that's land use, it's a football field, because we can say this segment has a certain size and a certain shape, and it is short grass, and it is surrounded by something that is red, so it seems to be a football field. This is the concept I've been advocating for 15 or 20 years, but we are actually now reaching a limit where AI comes in, and you can do most of that faster, sometimes more successful in terms of accuracy assessment. Not all of that, but still, I see big changes here. But we don't give up, of course. There are attempts to actually for a marriage of those worlds. So keeping some of these elements that build on hierarchy and scale and hierarchy in object-based image analysis, and then coming particularly with the deep learning. That was, I would say, the hot topic in 2022, 23, 24. We are now almost beyond CNNs and deep learning, but we see, and I can recommend this paper by Li Ma and others, very comprehensively investigate the landscape where deep learning and object-based image analysis came together. And now I think we are really at a point where AI is almost, it seems at least, that AI is almost taking over. Here we still have the patch extraction and using our classic methods, and then using the AI to tell us what it is. But when I looked at what Google brought up a few days ago with its agentic workflows that was published just a few days ago, this is almost frightening. You go to at the moment, it's not for every user free, but they show a video, and this will be released later this year. You go to a website and you ask in natural language, is it dangerous here under these hurricane conditions in this part of Florida where I live? And a geo agent would process your location and the data and the weather forecast and the wind forecast and the hurricane conditions, and it would show you on request how many vulnerable people live in this place. So it's like ChatGPT or many of these AI assistants, but we see now the advent of geo assistants. And I love that, and I saw that at LinkedIn, for instance, there were like 1,000 or so comments and likes for that. And of course, it's fantastic work, but it's really makes us thinking. And I think I have that on the next slide. No, the overneck. This is now what they're doing, and then I have the critical questions on the next slide. But what they're doing is fantastic. So they're buying enormous amounts of imagery, high-resolution imagery from Airbus, Maxar, and others, aerial photography, having all kind of openly available data like open buildings, OpenStreetMap, etc. And then they use their models to pose these questions, these spatial questions, and they call it geospatial reasoning. That's not only Google, of course. There are fortunately many other attempts, but Google is really, if you have a time to look it up, this Landgraf agent, that's really amazing. The current status. It's built on a vision language model. And this also seems to be a high trend. And I put here up a paper on purpose, not the one from Google, but here a group from mainly China and in the group from Technical University of Munich. They systematically looking now into the vision language models. Now, natural language processing in computer vision paired with computer vision concepts. Enormously powerful, I would say. And that seems to show us the way into the future. So the question then is geospatial reasoning or geo AI the future, the solution for what I've shown in the beginning, namely, we should report on the status on the environment, on the compliance with environmental rules. And of course, geospatial reasoning is now is great. And the difference, and I put this in red color here, the difference is now that it's about spatial relationships, that the models start to understand not only there is many of something in the field or in the scene. There is many cars, there's many houses, or there's a lot of water. They now start to understand spatial relationships between them. And this is fantastic. This is a step forward. But I'm saying there's always a but in life. But the point is, how can we ever evaluate what we get out of that? So who defines scales? How are they to be predefined? How can we validate the result? For instance, how do we know which training data have been used for that model that I just type in now and using one of these agents? And I should, according to all theory, I should not use data that have for validation that have been used for training, but I probably don't know the training data. So And then also what I've shown in the first part, so the more subjective things, can we also integrate that? So I would juxtapose here now, and this I'm coming already almost to the end of my talk. I try to be brief here, to have also some time for discussion. I try to juxtapose all the work from us, colleagues of mine, on scale and hierarchy, and juxtaposing that with what AI does now. And so I think it is, so citing myself in an old paper, it's not necessarily about running bigger problems on bigger computers with more data. Yes, that helps in many cases, or we have to do that, no question, and that brings about enormous possibilities that haven't been possible before. But it's not always or not necessarily a solution to a particular problem. So I claim that it particularly needs creating open and flexible software infrastructure that allows non-experts to intervene in a workflow at a particular point. This is what I'm a bit scared at the moment in these vision language models. That for me it's a black box. But again, the results are promising. And it requires more than layer stacking, Earth observation images or GIS layers. We need concepts of hierarchy, of regionalization, as we've seen before. Regionalization, not just in images, regionalization in terms of thematically relatively homogeneous areas, objects, building relevant objects based on pixels or beyond pixels. And we should enable a level of complexity that matches the specific interests and background knowledge of the user. And this is, again, sorry, that was the last slide for, at least I have some extra slides for discussion if there is time, but I try to be brief on that. So don't take me wrong, I am really puzzled by these very recent developments in particularly, as I said, in vision language models. But here I bring up my kind of concerns or research questions or questions that we need to tackle. And I'm very much looking forward also to a discussion where you might say what you think about these developments. And if you ever have time to come to the beautiful city of Salzburg, we are running a conference. I forgot to mention it here in July, the AGIT conference, and we're having a master's program on Copernicus Digital Earth. Thank you very much for your attention and for the opportunity to talk to you here.